This video is a continuation of 2.6 related rates from Cal 1. Alright, looking at the second example, this one says a spherical balloon, alright, so spherical is the key there, is inflated with gas at a rate of 1200 cubic centimeters per minute. How fast is the radius of the balloon increasing at the instant the radius is, and we're looking for 40 centimeters and 70 centimeters. Alright, so if we're thinking about a sphere, alright, once again we're thinking about volume. So if I'm looking at the volume of a sphere, I need to find the formula for that. And the formula for the volume of a sphere is volume equals 4/3 pi r cubed. Alright, so then let's go ahead and take the derivative because we know we're going to need to eventually. Let's just go ahead and do that now. And then we'll go back and look and see what rates we have and what information we may need to substitute. Alright, so I'm going to take the derivative of both sides with respect to t. And instead of writing out all the steps, I'm going to do like I did last time. Just kind of do the derivatives as I go. Alright, so the derivative of v with respect to t, these two don't match up. Alright, so I'll have the derivative of v with respect to t times 1, which is just dv over dt. Then I'll have 4/3 pi. And then the derivative of r cubed would be 3r squared. Alright, because I'm taking the derivative of r, alright, but I have a t on the bottom, I gotta have dr dt. Alright, so if I combine those together, I can do a little simplification here. When I say 4/3 times 3, the 3's will cancel out and leave me 4 pi r squared dr dt. Alright, so this is the formula we're going to need to use. Alright, now let's see, what does our problem tell us? What information does it give us? What rates? Alright, so when I look here, it says that the balloon is inflated with gas at a rate of 1200 cubic centimeters per minute. Alright, that is not, the radius of the balloon isn't growing at that rate. Alright, but the volume of the balloon is what is changing. So the derivative of v with respect to t, the volume, alright, is changing at a rate of 1200 cubic centimeters per minute. Alright, so you got to pay special attention to what is actually doing the changing. And it says the balloon is being inflated, so that means its volume is what is changing. Alright, and I want to know how fast is the radius of the balloon increasing. So what I need to know, or what I'm going to solve for, is the derivative of the radius with respect to time. Alright, so that means I need to come back down here and solve this for dr dt so that I can fill in my dv and my r and solve for dr dt. Alright, so to do that, I would divide by 4 pi r squared on both sides. Alright, and that would leave me the derivative of the radius with respect to time. Alright, so this is how the radius is changing with respect to time, would be 1 over 4 pi r squared times dv dt. Alright, so I'm finding how is the radius changing with respect to time, which is what this is asking me to find. Find how fast is the radius of the balloon increasing at the instant the radius is. And so the first thing we want to try is 40 centimeters. Let's see, make sure you can see what I'm doing here. Alright, so we'll say dr dt equals 1 over 4 pi times r squared, so that'll be 40 squared, times dv dt, which is 1200. Alright, and if I multiply that out, I'll have dr dt equals 1200 over 4 pi times 1600. Alright, and then if I do some simplification, I'll have 4 going to, we could do it like this. We could simplify the 1200 and the 1600, like that. And then I could say 4 going to 12 3 times, and have 3 over 16 pi centimeters per minute. Alright, now when we squared that right here, the radius, this would be 40 centimeters squared. And remember, this is centimeters cubed, so when I divide, I'm left with just centimeters, alright? The centimeters cubed divided by squared leaves me just centimeters, alright? Then it asks us to find it when the radius is 70 centimeters. Alright, so I can say that my radius is changing. Alright, per minute, I would say here 3 over 16 pi centimeters per minute is how fast my radius of my balloon is increasing. Alright, so let's try it with 70. So we'll do the same thing. 1 over 4 pi times 70 squared times 1200. And remember, this is centimeters cubed. That would be centimeters. Alright, so I got everything filled in. I'll have 1 over 4 pi times 4900 centimeters squared times 1200 centimeters cubed. Alright, now let's just go through and do some simplifying here. Alright, so I'll have, let's do it like this. Let's write it like this. $1,200 centimeters cubed. Alright, now I can simplify those. And I can do it like this. I could say 4 into 1200 would be 300 cubic centimeters over pi times 4900 centimeters squared. And then cross out the zeros would leave me 3 over 49 pi centimeters per minute. Alright, so the radius is changing at 3 over 49 pi centimeters per minute. Alright, let's see.